Hey y'all, today we are looking at the area of a shaded region. Last time we looked at the area of a composite figure where we took a whole bunch of smaller figures and pushed them together. Today we're going to look at a shaded region, which means our two shapes are actually inside of each other, or even have more than two shapes if we want to. Okay, so to do this when the shapes are inside one another, okay, what we're going to do is we are going to find the area of the entire figure. So whatever is on the outside is what we're going to look at first, and then we are going to remove this unshaded part. We are going to do that by subtracting, okay, the area of the non-shaded figure, which is usually the part that's on the inside. Okay, so a formula that you can use is area of the outside shape minus the area of the inside shape, whatever they are. Okay, that gives you your formula for area of a shaded region. Area of the outside minus area of the inside. Okay, so we have a couple examples to look at today. Okay, the first one is pretty straightforward. We have, what shape is this on the outside? Yeah, that's a square. So we're going to do the area of the square, which is on the outside. And we are going to subtract the area of the shape that's on the inside, or this whited out portion. What shape is that? Area of the circle. Okay, so, and we are going to subtract those two things. Subtract, subtract, subtract this time. Okay, all right, area of a square is base times height. On this square, we know that one side of our square is 25, which makes the other side 25 as well. So 25 times 25 is 625. That's the square. And then we're going to find the area of this circle. The formula for area of a circle is pi r squared. So what do we need in order to find the area of this circle? We need the radius. So the radius starts at the center and goes to one edge. Okay, so is this the same as this 25? Is this the same? Nope. How much of that 25 is this? It is half of it, and half of 25 is 12.5. Like this would be our diameter all the way across the middle of our circle, so the radius is going to be 12.5. Pi times 12.5 squared. Pi times 12.5 squared is 490.87. So this is the whole square on the outside. The circle is the inside part. So what are we going to do with those two numbers now? We are going to subtract them. So 625 take away 490.87. Okay, and I'm only going to write that this one time. From henceforth and forevermore, I will just do that part on my calculator. Okay, so 625 take away 490.87 leaves me with an area of 134.13. What's our label for this? The numbers are in feet, so feet squared. Sorry. Okay. Well, that seems a lot easier than the ones we did last time, huh? A lot less work. All right, again, shaded region, area of the outside minus area of the inside. All right, so here's number 2. Pause, draw a picture. Okay, think about what shapes we have this time. Okay, for this shaded part, okay, I do not have a formula that allows me to find the area of that shaded part. Even if I drew a line right here and I divided it into 2 trapezoids, I wouldn't have enough information to be able to find the lengths of those pieces. So I'm going to use the area of the shaded region. The area of the outside part is a rectangle. Area of a rectangle is simply base times height. the area of the part that we're removing. Now removing, remember, so this is the whole thing. This is the outside part, right? The whole outside part. And this is the smaller part, or the part we're cutting out, or the inside piece. What piece do you see here on the inside that's being removed from this rectangle? That is a triangle, which is 1/2 base times height. Okay, once I have those two things, we will subtract and we'll be done. Okay, so what are the dimensions of this rectangle? The dimensions of the rectangle, if you just trace around the outside of that rectangle, you're going to see those values. So we've got a 14 across one side, and we got a 25 across the other side. 14 times 25 is 350. That would be if this whole thing was shaded. But if we cut out this triangle, we're going to subtract that part off. So we're going to subtract off 1/2 of the base times the height of this triangle. So I'm going to turn this sideways for just a second, because I like my base and height to make a right angle to me. So this is the right angle. So all of this from here all the way down to here, that's going to be the base of this triangle. How long is that line? This line from here to here is the same as this line up here across the top. So all of this is going to be 25 for the base of our triangle, and the height of our triangle is 11.3. Okay, you don't have to do Pythagorean theorem every time, only if they gave us that diagonal, right? So 25 times 11. Uh-oh, I think my pen's about to die. 1/2 of 25 times 11. 1/2 of 25 times 11 is 137.5. Oh, my pen's dying. Okay, 137.5. What am I going to do with these two values now? This is the outside shape. This is the inside shape. We are going to subtract them. So 350 take away 137.5 is 212.5. And we go back and put a label on it because that's what we do for area and perimeter. Boom. Okay. You know what? You know what, y'all? I'm going to change this. I do not want to do this problem right here. We're going to change this. Okay, we are going to look at a circle with a smaller circle inside it. Pretend that's pretty. Okay? Alright, so what we're going to be told is that from here down to here is going to be 10 feet. Okay? And we're going to be told from here to here is 3. Okay? And the shaded region is going to be kind of like a dartboard, sort of, where we have this shaded area around the outside of our dartboard. Okay? Kind of a reverse bullseye. Okay, so in this case, what shape do we have on the outside? Okay, we have a circle, but in this case, I'm going to call it a big circle because there's another circle there too. Okay, so we're going to take the area of the big circle as the outside part, and then we're going to cut out the smaller part, which is the area of that smaller circle. Okay, SM for small circle. Okay, area of a circle is still pi r squared every time. All right, so starting with the big circle, if this from all the way here to all the way to here is 10, what is the radius of this bigger circle? Okay, all the way across the circle is 10, so halfway across the circle is going to be 5. Okay, so you can draw it whichever direction you want to go. The only reason I didn't draw it on this side was because I already got that 3 over there. Okay, so on my big circle we have a radius of 5, so pi 5 squared. I could do that in my head. That's going to be 25 pi. We'll deal with the decimal in a minute when I type in my calculator. Okay, let's look at the smaller circle. So the smaller circle has this piece. Well, not really. That piece is not really given to us, is it? We're removing this 3, this shaded part right here. That's 3. How much is left inside the circle right here? Okay, I'm going to do that again. If all of this is 5 from the center out to this edge, but this shaded part is 3, what's that going to leave here on the inside? It's going to leave 2. So the 5 was the radius for the big circle, and the little circle has a radius of 2. Pi 2 squared. So that's only 4 pi. Okay, so the 3 is taken off from the 5 that we already know. We're going to subtract these. 25 pi take away 4 pi is really 21 pi, and you could technically leave your answer like that, but if we wanted to multiply it out, 21 times pi gives us 65.97 or 66.0, whatever you want to be specific about. Okay? Yeah, y'all are going to see those kinds of problems. So sometimes they give you the radius of each one. Sometimes they tell you how much bigger one is than the other. So you just kind of got to use your brain a little bit on that. I know that's hard sometimes, but you know, that's what they ask us to do. Life. Okay, last one. Let's see. So we got this wonky shape along the outside. And then we're removing this white thing right here, which is what? That's a semicircle. So if I made this solid here and I shaded all of this in, what shape would this be that was completely shaded here? That would be a trapezoid. And then we're going to be removing half of that circle, or the semicircle. Okay, so trapezoid is half base 1 plus base 2 times height, and half of a circle is half pi r squared. All right, so let's start with the trapezoid, I guess. Where are the two bases? Okay, remember the bases are the two parts that are parallel to each other. Okay, so that's going to be this 17 and this 37. Those are our two bases. So I'm going to do half of 37 and 17, or you can do 17 and 37, doesn't really matter. Okay. All right, and then we got this 25 over here. Is this 25 the height? Crossing my fingers, please say no. This is not the height. Okay, you do not go to the doctor and lean on the wall like this and say, go ahead, doc, tell me how tall I am. Okay, when you measure your height, you always stand up straight. So the height is going to come in like this at a right angle. This is the height, not the 25. Okay, however, we can use that 25 and part of this 37 down here. Do you see this shape right here? That's a little right triangle. So in order to find a missing side of a right triangle, we can do Pythagorean theorem. Okay, so I've got a 25 right here. The question is, how long is this bottom of this triangle? Because that is not 37. Please, please, please don't say that's 37. 37 goes all the way from end to end here. Okay, so this piece is chopped off from that 37 this much. How much is this line right here on our shape? This line from here to here is the same as this line up here at the top, the 17. Right? So if all of this is 37 and we're taking away 17 of it, 37 take away 17 leaves 20 over here for this side down here at the bottom. So this right triangle, we're going to do Pythagorean theorem to find the height. We've got a 25 squared and a 20 squared. Do we want this height to be bigger than the 25 or smaller than the 25? This should be smaller. 25 is the hypotenuse, that's the biggest. So 25 squared take away 20 squared. Oops, that's not square. Leaves 15. So this height of our trapezoid is going to be 15. So that's going to go for H on our trapezoid. So we got the height of 15. We've got our two bases, top and bottom, 13 or 37, sorry, and 17. So I type that in my calculator. 0.5 parenthesis 37 plus 17 times 15 makes 405 for the big old trapezoid. And then we're going to take out, we said, this little semicircle right here. Okay, so on a semicircle, we only need the radius. Okay, so where does the radius of a circle go? It goes from the center to the edge of our circle. So we could draw it like this, or we could draw it coming down like this. Okay, either way, they're the same value. Okay, if I go this way, does that line have anything to do with this 17? Sure, it's part of it. Do I know how much is chopped off of that 17? Do I know this value from here to here? Say no. No, I don't. Okay, so let's go the other way. Let's go this way. Okay, how much of this line from top to bottom, this line right here, how much of that line is colored in right here for this radius? Exactly, it's half, right? Half. So do you see this same line from top to bottom? Do we know how tall that is? Do we know this line right here? That says 15. So this piece right here, this little bit right here is 15 divided by 2. It's half of 15, which is 7.5. So that's going to be the radius of our circle. So I'm going to go over here to my formula. Half of pi 7.5 squared. Calculator, half pi 7.5 squared makes 88.36-ish. And our last step, do we want to add these together? Are they beside each other and being combined, or is one inside the other and we're going to subtract them? Yeah, subtract. So 405 take away, 405 take away 88.36 makes 316.64. And what's our label for this? These are centimeters. So centimeters squared. Cool. Okay. So area of composite, find each area, add them together. Area of shaded region, find each area, subtract them. Again, remember it's outside first minus whatever's on the inside. Okay? Again, y'all got questions? I know these are different. This is where we would start doing lunch tutoring and coming and asking questions. Okay? So you know how to find me. Send me a text. Come find me in the Zoom. Please, please, please ask questions. Okay? All right. Love you. Bye.